So today we are going to determine if quadrilaterals that we are given are parallelograms. And what are some things we know about parallelograms? The parallelograms are opposite sides are what? Parallel. Good. They never run into each other. What else do we know about their opposite sides? They are what? Equal. Good. What do we know about their opposite angles? Opposite angles are equal. What about the angles next to each other? Yeah, the 180. What do we know about their diagonals? Not necessarily. Not for just a parallelogram. What do they do to each other? They bisect each other. Okay? Well, that's the method we are going to use to show that a quadrilateral is a parallelogram. We're going to show that their diagonals bisect each other. Okay? To do that, all we have to do is just find the midpoints of the diagonals. If they're the same, we know it's a parallelogram. If they're not the same, then it's not a parallelogram. So first things first, what should we do with these points? Plot them. So we're going to plot -2, 3. We're going to plot 4, 3. 2, -2. And -4, -2. Make sure you label your points. This is L, M, N, and O. And you just can't look at the picture and say, yeah, that kind of looks like a parallelogram. Sure, yes, looks like one. You have to do the math to show it. So what we're going to do, draw in your first diagonal. We'll start with L. L matches up as across from which point? N. So there's one diagonal. Find that midpoint. Okay? L and N. Did you have a question? Okay. To find the midpoint, remember, what do we have to do with our x values? We're finding a midpoint. This is L, N. You add them, good. Don't subtract them. Add them always. Add them. And divide by what? 2. So if we look at L and N, what are our x values? -2 and 2. Add those together. Divide by 2. What are our y values between L and N? 3 and -2. Add those together. Divide by 2. Always add. Always add. Well, clean it up. What's -2 plus 2? 3 plus -2? 0 over 2 is, and we can't simplify down 1 over 2. There's that midpoint. Repeat the same process for the other diagonal. So draw that one in. 0, sorry, matches up with M. So find the midpoint between those 2 points. So M and O. Same process. Add the x values, divide by 2. Well, what are our x values between these 2 points? 4, -4. So we're going to add those guys together. Again, always add, divide by 2. What are our y values? Add those together, divide by 2. Clean it up. 4 plus -4? 3 plus -2? Clean it up. 0 over 2 is 0. Can't simplify down 1/2. Are these the same? Yes. So that means these two lines you drew meet at the same exact point, which means they bisect each other. So when that happens, when they're the same, you just say yes. Diagonals it's a parallelogram, the diagonals bisect each other. Question. Add the x's divided by 2, add the y's divided by 2. For the first diagonal, do the second diagonal. If they match up, you know you have a parallelogram. If they don't, if they're not the same, then you know it's not a parallelogram. Just say no. Diagonals do not bisect each other. Okay? Questions over that? Nope, I just the same thing. Yep.
All right, so let's prove quadrilateral coordinates. There they are. Little buttons and parallelograms do the same exact kind of thing. But first we need to do what? What? Plot the points. Go ahead. Let's plot P, Q, R, S. Go right ahead. P, 1, 1. There it is. The other one is 2, 4. 2, 4. Oh, there goes P. P, Q. The other one is 5, 6. 5, 6. That is R. The last one is 4, 3. 4, 3, and that is S. Let's go ahead and connect our figure. See what it is. You can just draw and recognize what it looks like. All right. Is that a parallelogram? Some people look at it and say yes, no, I don't know. Well, let's go ahead and do the same thing. Let's check the diagonals here. All right, well, what diagonal do you want to do first? Doesn't matter, we're going to do both. What do you guys want to do first? QS? All right, so that little guy right there. So we're going to analyze QS first. Change the color, nice little cute green action. Let's go. That guy. All right, so when we're doing that, we're looking at QS. Here are our points, Q and S. So let's go ahead and figure out what it is. So QS. Well, we're going to find the average. We're going to find that midpoint of that segment and see if it's the same for the other one. All right. So we're looking at QS. Let's label our points to help ourselves out. X1, Y1. Oh, that is not good. X1, Y1. There we go. X2, Y2. There they are. Let's find the averages of the X's. So this one and this one. All right, give me one of the X's. Up here, give me one of the X's. 2. That was a good one. I'm going to add that with the other X, which is 4. Very good. Over 2. We're dividing by 2 to see what that midpoint is. The next one over here. Let's do the Y's now. Give me one of the Y's. 4 plus 3 over 2. Nice job. Awesome. We should always reduce our properties here. Reduce that. So 2 plus 4 is 6 over 2 still. The other one is 7 over 2. There we go with that. I'm going to keep it in practice for me. Okay. And the last step is we need to reduce this. So 6 over 2 reduces to 3. 7 over 2 reduces to? What do you say? 7 over 2. Maybe like that. 7 over 2. And that's what we got. Good. Remember, that's really the same as 3.5, too. Help you guys out. All right, that's the middle of it. If I had to plot it, it's right in that range somewhere around there. Well, great. Let's look at the other one now. And the other one half, what's the other segment going to be? Let's go nice bright green here. What is it? PR. PR. Oh, of course it did that. Come on, buddy. Let's go. On that vibrant green. There it is. Woo! It's vibrant. So let's do this one now. I'm going to do green. We are looking at PR. Personal record. Well, the points are over here now. Again, label them X1, Y1, X2, Y2. Plug them in. Give me one of the X values. 1 plus, what's the other X value? 5, still divided by 2. The Y's now, the first one is 1, plus the second one is divided by 2. All right, simplify here just a little bit. 1 plus 5 is over 2. The other one, 1 plus 6 is 7 over 2. already you can see what's going to happen. And when I do so, it's going to reduce down to 3 7/2. So, do these diagonals bisect one another? Do they both intersect at the same point? Yes. So I would say, yes, the diagonals bisect. Questions with that? Pretty straightforward. Again, remember that, how to find the midpoint formula. All right. We go on this one.
Yep. So we just looked at how to determine if a quadrilateral is a parallelogram. Right? Well, now we're going to look at specific types of parallelograms, which is a rectangle. We want to show that a given quadrilateral is a rectangle. In order to do that, you need to show that it is a parallelogram. Because if it's not a parallelogram, then it's not going to be a rectangle. Right? Once you've shown that it's a parallelogram, then you have to take the steps to also show that it's a rectangle. Okay? So first things first, what should we do with these points? Plug them. Okay?
Good idea.
-3, -2, which is M. -4, +2, which is A. Q4, which is T, and 3, 0, which is H. We need to show that this is a rectangle. Okay? Well, you just can't look at it and see like, yeah, that kind of looks like a rectangle. Sure. Looks like there's 90-degree angles, or it looks like those opposite sides are the same. Yeah, sure. It's a rectangle. No pun intended, but you have to do the math to show that it is one. You just can't determine it by looking at it. So do exactly what we did. Show us a parallelogram. Okay? How to connect your diagonals. A matches up with what? H. H first. So again, what do we do with our x values between A and H? Add and divide by 2. So our x value with A is -4. Our x value with H is 3. Divide by 2. Do the same thing again with the y's. There's our y values, add them together, divide by 2. Everyone okay with that part? First, we have to show it's a parallelogram. We're doing exactly what we did in the other problem. Well, what do we get when we do -4 plus 3? What do we get when we do 2 plus 0? 2. Can't do anything with 1/2. 2 over 2 reduces to what? 1. There's the midpoint of that first line. Repeat the same process with the other two. M matches up with T. So M, T. Same thing. What are our x values with M and T? What are our x values with M and T? Leah?
The x values would be -3 and 2.
Good. We're going to add those up. Divide by 2, column. What are our y values with M and T? What's the y value of M? -2. Good. What is the y value of T? Divide by 2. Keep cleaning it up. -3 plus 2. And -2 plus 4. And again, you will see these are the exact same thing. So you're going to get the exact same answer. So do we know this is a parallelogram? Yes. So it has the potential, because it is a parallelogram, to be a rectangle. Well, what's special about rectangles? What do we know about their angles? They're all what then?
90.
They're all 90 degrees. So if we can show that we have 4 90-degree angles, 4 right angles, then we know it's a rectangle. Well, similar to what we did with triangles, what kind of lines form 90-degree angles? Press P. Talk about it on your quiz. What are they? Perpendicular. Well, how do we know that two lines are perpendicular? What do we look at? Lexia? So, what are the same? If we know you're right with parallelograms, we're trying to show that two lines are perpendicular. What do we look at? They're slopes, right? It's really nice. So you might think, oh, we have to find that 4 right angles. Really, you only have to do one. Because remember that theorem from last unit? If you have one right angle and a parallelogram, the rest of them are going to be right angles. Okay? So pick any angle, A, T, H, or M. M. Okay, pick that. Find the slopes of the two lines that are touching M. And again, we use find the slope by counting. Okay, so let's find AM first. Count. 1, 2, 3, 4. We went. What did I do? Ah. Counted a little too far. 1, 2, 3. We went down 4. So it's going to be positive or negative? Negative. And we went right 1, so it's going to be positive. So there's the slope of AM. Okay. Well, find the slope of this other line, HM. How far do we go down? How far do we, so it's going to be positive or negative if we went down? How far do we go over? What is -2? And we went to the left, so it's also going to be negative. What is -2 over -6 simplify down to? 1/3. Are these opposite reciprocals? No. Yes, they're opposite signs. Yes, one's over 1, the other one's under 1, but that bottom number is not the same. So these are not opposite reciprocals. Which means this guy right here, M, is not a right angle. So because it's not a right angle, is this a rectangle? No. So your answer just means no, no, right angles. No.
So those who use the symbols, looks like a rectangle.
That not being one.
Because there's no other opposite systems. So in order to be a right angle, it's like vertical.
Questions over that?
That's what AM is this. That's what
Same exact steps for 4. You want to show that it is a rectangle, you have to first show it's a parallelogram, and then determine it's a rectangle after that.
all right, well, just like we've done before, let's graph code here. Code. So let's go ahead, 0, 0. Nice and easy, right there, the origin. The next one is, I'm going to call that a C. The next one is going to be 5, 0, 5, 0, right there. Call that an O. 5, 2, 5, 2. That is an A. And the other one is 0, 2. Oh, I went too high on the second one, didn't I? See a dot. Move down a little bit. And then the other one is at a 0, 2. I'm going to call this A. This is T. And we'll connect it up. Let's go. Let's see what we got. Some of you are already thinking some things here, but we have to prove it. So just like before we're going to do, let's prove it is a parallelogram. How do we prove it's a parallelogram? You're saying it. The what? What are those things called? Cut across. Just bisect. What are those things? Those lines that go across. They do bisect. You're exact. They're stuff. The diagonals are bisected. Very good. So let's do a diagonal first. Let's find one of them. How about we do, I don't know, let's say CA. That seems like a good one, doesn't it? Let's do CA. Let's do that one first. See what we got there. So when I do CA, I'm going to leave myself some room here. Again, do that little formula, break it down. So C and A, call those X1, Y1. Again, you don't really need those, but I like to stay consistent because I do that all the time. So, do the X's. What's one of the X's? Hey, 0 plus the other one is 5 divided by 2. The Y's are 0 plus 2. Oh, I was thinking 2 in my head. Divided by 2. Good as far. We know we need to reduce. What is 0 plus 5? 0 plus 5 is 5. Yeah, no thinking there. Okay. Over 2. The next one is 0 plus 2 is over 2. We can reduce that a little bit. 5 over 2, is that going to be nice and neat? Does 2 go to 5 evenly? No, so it's going to say 5 halves. The other one, 2 over 2 gives me 8. 1. All right, good so far. That looks like a good point. Now let's find the second intersection. Second intersection, let's do this nice blue. Okay, when I do so, we're talking TO. Ha! Trello. Football player. So we're saying TO. The same thing we did before. And again, guys, some of you are like hung up on the order. It doesn't really matter. If I say TO, I'm still going to do the same thing. X1, that's an X. Y1, X2, Y2, and let's go. All right. All right. My first X is? What first X is? 5 plus the second one. I don't know what it is 0 over 2. Next one, do the Y's. It is 0 plus 2. Huh, weird. Divided by 2. Reduce that down. 5 plus 0. Again, gives you 5 over 2. 0 plus 2 is 2 over 2. We do need to reduce. It's going to be 5 halves over, or beside 1. What do we notice? They're the same. Again, you could have got that from that step there. Nice. They are the same. So, the next thing we need to do is we're trying to see if it's a rectangle. Let's analyze one of those angles. It is a parallelogram because we know those diagonals do bisect one another. So the next thing is, let's find a right angle. Which angle do you want to prove is a right angle? See? Very good. We're looking at this guy. Is this one right here the right angle? Well, yes. Why? You have to do the slope. So, again, this one's pretty easy to see. This one's going straight up. This one's going over. This is undefined, going straight up, because we don't have a slope one way. And this is a slope of 0. So they are opposite reciprocals of one another. So yes, this is a rectangle. So yes, let's say right angles. It's a rec. This one you have to look at too, but you do need to prove that those are diagonals bisect one another. Questions on that one?
Go ahead, get out your practice. You have plenty.